Okay, so we're going to look at this question. It's in two parts. So the first part of the question says prove sec to the power of 4x minus tan to the power of 4x equals 1 minus 2 tan squared x. So our first thought here is that we have powers of 4 on this side and we've got only squareds on this side. So and I can also see I've got something to do with sec here and I've got something to do with tan here. So it feels likely that I am going to be making use of this identity. So I'll just make a little note of that on the side, and we'll come back to it. But it's not squared here; it's to the power of 4. So somehow I need to get that back down to squareds. What you might notice on this, and this is definitely one of those questions where if you can make the first step right, you're almost home and dry. But one thing that you could notice on this is that this is actually the difference of two squares. So this is sec squared squared, and that is tan squared squared. So we can write this what I should have said was I'm going to start from the left hand side and I'm going to go to the right hand side. Okay, so we can rewrite sec to the power of 4x minus tan to the power of 4x as sec squared x plus tan squared x, all multiplied by sec squared x minus tan squared x. So this is coming from this piece of algebra, which was GCSE work, wasn't it? So we're using that fact. So something squared minus something squared is equal to the something plus something multiplied by the something minus something. Okay, so that's where we've got to. So this is looking better. So I've got something to do with tan squared here, but I've got something to do with sec squared here. So can I change my sec squareds into something to do with tan squared? So yes, I can, because I know that sec squared of x is equal to 1 plus tan squared of x. So I'm going to write this as 1 plus tan squared of x plus tan squared of x multiplied by 1 plus tan squared of x minus tan squared of x. You might sort of see what's happening here now. So if I can now simplify that bit there as 1 plus 2 tan squared of x, that looks very promising, multiplied by, those cancel out, 1. So that is equal to 1 plus 2 tan squared of x, which equals the right hand side QED. So that is proved. Right, so quite nice, and it was that first step that was the key. And I think with a question like that, we would quite often see students getting either no marks or all the marks, because if you don't see that first step, then it's very, very difficult. Okay, right, so we have proved the identity. We're now, the second part of the question then goes on to say, hence solve for x between 0 and 360, sec to the power of 4x minus tan to the power of 4x equals 3. Okay, now hence is always a big hint. So hence really, there may be other ways of doing it, but what it's saying is use what you've previously done. So what we had done before is we've proved sec power of 4x minus tan to the power of 4x is equal to 1 plus 2 tan squared x. So that we can rewrite as 1 plus 2 tan squared x equals 3. So let's simplify from there. 2 tan squared x equals 2. So tan squared x equals 1. So tan of x, a very common mistake at this point would be losing one of the solutions by forgetting that tan of x can also be minus 1. So if tan squared of x is 1, then tan of x is plus or minus 1. So once we're at that point, we are into our calculator mode, just to make life a little bit simpler. I've already graphed it. And we do our g-solve, we go across, we do xcalc, and we're going to solve it for x is 1. So I've got x is 45, and I've got x is 225. Do g-solve on the same thing, and I'm going to do it for x is minus 1. And I've got x is 135 degrees, and x is 315. So that was, so x is 45 and 225, and x is 135 and 315 degrees. Okay, and those are your answers. Fairly tricky question, but just a little bit of thought at the start. Get into it the right way. It's really quite manageable. Okay, hope that helped.